I should be able to fill in gaps. Somebody else to help Christian?
I can also try to add some notes.
Okay, so yeah, when you're not presenting.
Of course.
Okay, yeah. So that would be great. And if anybody else can help Christian while Hannes is presenting during the firmware encryption part, that would be great. But all right. Do I have my co-chairs? I saw Dave Waltermeyer on briefly a minute ago. He's having connection problems. All right, I have that it's time to start, so I'm going to go ahead and start then. All right, so welcome to the suit working group. Sorry, I don't know how to use the advance to next slide when it's all in PDF here and here, and I don't want to spend time to figure it out, so I'm just going to scroll here. This meeting is covered by the note well. Presumably at this point in the week, you've seen this many times. If you haven't, please read through this. It's in the slides linked to this session that you can find in the meeting materials tab. On the top right is the folder icon to get to the meeting materials. And you can find all the slide decks from today under the folder icon on your screen. All right, we just talked about note takers. We have Christian and Hannes as our note takers. And we do not need a Jabber Room watcher based on the latest discussion unless somebody tells me otherwise. I'm going to skip that. This is our agenda for today, split into 2 slides. So logistics from the chairs. We'll talk about hackathon things, suit manifest format, the firmware encryption. This is what is posted here is suit reports and suit mud. But last I heard, the authors did not have any open issues to discuss. And so that could be like open mic time if people have things to bring up. But I don't believe we have any presentations on either of those. Brendan, let me know if that's incorrect, but that's what I understood from the email threads that we had. And we do want time to talk about the recharter discussion, which I think are currently in the chair slides. And so we could put that under logistics. Although I'm thinking we might want to do that at the end after we've had discussion about these drafts, but I can go either way. And since I don't see any of my co-chairs here, I'm thinking that I would rather wait till the end because that's when the co-chairs will be here. I do see Roman is here. That's great. As long as Roman, you can be here for the full session, then I'm going to move the charter discussion stuff to the end at point 7. In the hopes that Russ.
No worries.
What's that?
I will be here for the full session, so no worries
Okay.
if we want to move up or do whatever we want.
Okay, great. Then I will hold that till the end in the hopes that Russ and or Dave can be here along with me for the recharter text discussion. So, all right. So our current milestones, we have 1 remaining milestone on the current charter, hence our discussion about what should be in the updated charter. Which was originally March 2020 when COVID happened. And so we're still trying to finish up the manifest format. And so we believe we're really close. And so that's the main item for today. If we can get through the manifest discussion, get through the fact that we believe that it is ready for the next step, that would be great. And so that's everything else is secondary to that particular work item today. At this point, these are the slides for later on, and so I'm going to stop here from the chair slides, and we're going to move directly to the hackathon slides. And so let's see, who's presenting the hackathon? Is that Hannes? Yeah. Do you want to share your own screen, Hannes, and present the hackathon slides?
Oh,
or do you want me to?
Okay.
I can do it either way.
Yeah. Let me try it. Let me try.
Okay, just because I'm in the scrolling mode, and if you can get into the next slide mode, then
yeah. Okay.
Why don't you try?
Trying to find out where the button is to do that.
And I do see Russ just joined us. Russ, I was just saying, since neither you nor Dave Waltermeyer were here right when I was saying this, we're going to do the charter discussion at the end because I did see Dave Waltermeyer pop in and then disappear. And so I stopped advancing the chair slides when we got to the charter stuff, saying let's do that after the other presentations. Is that okay with you, Russ?
I'm sorry, I'm late.
Okay. All right, so we're going on to Hannes's hackathon report, and then when we get past the firmware encryption, then we'll come back to the charter discussion. And we'll firmware encryption goes too long, we're going to call time because we do want a couple minutes at the end to talk about the recharter discussion. So
yeah, can you see my slides?
I don't see them being shared yet.
Okay.
Although, okay,
Yeah,
grant
because we
screen.
didn't
Acknowledge
say
Hannes'
yes to
request.
share.
There you go. Now we're going.
Okay. Let me see how easy this works. Can you see it now?
Yep.
Okay, cool. Yeah, I will try to be brief because we have so many things to discuss. Does it still work?
Yep. Do you want to turn on your video?
I could, yeah. If I
Also, can you full screen it?
I thought I did. Oh man. Okay.
No, you probably did, but Meeting Hood grabs the desktop view, I think.
Okay. All right. Is it any better now?
Yeah, just close the side panel and move on.
Okay. Sorry about that. Is it better?
Good enough. Let's not spend time on this.
Okay. Terrible.
Not change the detail.
Yeah. So you may have seen that I sent around an email before the IETF meeting to talk about having a hackathon and kind of a bigger project picture in some sense, not just focusing purely on the work of the group, but instead also looking at how does the firmware get there, and like the whole chain essentially. And so we, based on the participants who said that they want to join, which I was surprised given like the online experience of a hackathon is kind of clumsy. So we had one group working on actually the transport, and they used lightweight M2M. And with their focus, they wanted to do some OSCore because that was not available at that time. In the deep group, there was a presentation already, which I'm going to skip now. And then there's the work on the manifest itself, and then to actually use that new software as part of the secure boot mechanism. And so a couple of things got done. I skipped the first few and focus on the last one, which are relevant to this group. And there are a couple of pointers to repositories, ongoing work, of course, and big thanks to David Brown, who helped me to with the integration of Suit into the MCU boot, which like when you initially create the plan to do something, it always looks easier than it actually is. So it was amazing to see that there's actually a separate simulator in MCU boot to simulate updates and particularly failures to updates, like what happens if the update gets interrupted, if there are mistakes with flash writing and flash access and so on. So really cool stuff in terms of testing. Maybe something to look at for other people in other projects. Brenton did an update of the manifest generator. Our Japanese friends worked on on one of the parsers, which I used, and so that I tried to pull that together. And I have one slide, or is it or maybe two slides, on explaining a little bit on the details of one specific aspect, which I thought could be interesting to the group as a sort of a background. In MCU boot, open source bootloader, which many of you know and which is used in other embedded operating systems. There are different slots, and each slot has a firmware image in there, or potentially has a firmware image in there. But there's also some additional data there, particularly header, which describes what follows afterwards, so you can actually see like lens information
So,
and so on.
Hannes, we're
Yes?
still on your title slide.
Oh man, really?
Yeah.
Maybe you guys can present because that is a little bit painful. And I don't really know what I should do to make that, to change that.
Get your slide 4.
So now I'm slide 4.
Yep.
Okay. Okay. So that's good. As I would like to show slide 4, and ignore the details of how this looks like, but the general idea I think is important. So then there's the firmware image, and the firmware image is today followed by a couple of DLVs, and that's the way how these descriptive firmware images or firmware updates look like. And there's also a trailer in quotes which stores information about what happened to the update, which is quite important as you need to record what actually, or the bootloader needs to record what image it's using, what the encryption keys are to actually then subsequently decrypt it, etc., etc. And the features, and you see that in that box here with the DLVs, each new DLV adds a feature like different encryption, different algorithms, and so on. And that's sort of like the whole flow of processing sort of follows by going through the DLVs and then looking like what feature was implemented, and then actually executing that. And that, as you can imagine, as we are sort of incorporating the suit functionality, that changes quite a bit because we have these behavioral manifests. And so what we then discussed and decided to do is we still use the same header format, add a new magic number, repurpose one other field to know the size of the manifest, and then just attach the manifest at the end of the firmware image in this specific slot, and still stick with the trailer because that's obviously needed, and then use a bunch of different software libraries to accomplish this task. And some of it is not yet published. I need to find a good home for it, but other things are available as the links previously indicated. I'm also going to, Brendan released his parser, which is quite minimalistic. So I'm trying to compare the size of those and to come up with some performance numbers as well, just for your interest in depending on which features you like. This one, the current code that I've been working on was using the embed DLS and sort of some of those features, and Lawrence's QU, CBOR, and DCOSI library. So that's about the bootloader, and I will post a link to the list when the code is once I figure out where to put the code. We had a few challenges as well, but overall, I think the key message I want to get away with is, like, although like this virtual environment is pretty much discouraging for hackathon participation, I thought it was still a great experience because there are always some people around that you can ask, and I have talked to obviously to the other team members, but also to others who hang around in the hackathon. And there's always something that you get away with, something you haven't known before. So for me, this was a plus, despite all the minuses with time zone differences, etc. And a big thanks to the people who participated and helped out. Okay, that's all I want to say about the hackathon. And just drop me an email if you are interested in specific details.
All right. Thanks, Hannes. Any questions for Hannes? If not, then we will move on to the suit manifest. And I have those slides, or Brendan, you can share if you prefer, but otherwise I'm ready to project, whichever you like.
Either way. So, well, maybe it's easier if I advance them myself.
Yeah, then you'll have to say next slide. If it's working for you, go ahead and
let's give it a go and see what the experience is like, and we can always revert if it's not working for us. All right. Let's see if this works. All right. So here's roughly the topics I want to cover today. So there's a few minor issues that we probably need to discuss. And then there is the major issue of document structure, which I will, of course, come back to. But I thought we should clear out the minor ones first, since I think they should be reasonably easy to get through. So we are already using URI fragment-only references in one section of the document.
Brendan?
Hello?
Would you like to turn on your video while you're presenting so we can?
Oh, sure, yeah.
Great, thank you.
There we are. Yes. So URI fragment-only references are already referenced in the document. So I think it is just an oversight that we aren't saying that the URI is a URI reference. So in my opinion, what we should do is we should switch to, we should make the formal definition of what's actually in the URI parameter a URI reference. I don't think this is a big change. It does produce one interesting question, which is, if you have a relative URI placed there, what is it relative to? The best answer that I have for this, and the only thing that really makes sense for me, is if we are using a relative URI and the reference URI is present in the manifest, then if both of those conditions are met, then the relative URI should be relative to the reference URI. Otherwise, I think it should be undefined. Beyond that, I'm not sure. So if anyone has any strong opinions, please let me know. Okay, next.
Do you mean illegal, or do you mean implementation specific?
I think implementation defined is probably the right answer here, because I can imagine there being situations where that kind of thing is well known in a particular deployment. The idea of having a local cache server, for example, comes to mind. And if devices happen to know about their local cache server, then that's probably fine. But there's no way to specify that without having a, devices know the MDNS name of the local cache server and the local cache server conforming to that MDNS name, for example. So I think it's better to have devices know what to do themselves, and then it just becomes implementation defined if there's no reference URI present.
Okay, I see Michael Richardson in the queue. I assume on the same topic. Go ahead, Michael.
Hi, thank you. Yeah, I think it's really I think it's really important that relative references work, because I think that's I think that's the best way to refer to other dependencies and make sure that they can get there regardless of how the initial parts are delivered via, and I'm thinking specifically about air gaps and USB keys and as you say, distribution servers. And so I really think I think it needs to, I don't like what I heard you saying, implementation specific. I think I'm going the wrong direction, or maybe I'm misunderstanding, but I'm thinking that maybe you mean it's specific to how you got the manifest. Is that what you mean? Or maybe I misunderstand.
I was trying to avoid enumerating all the possible ways that this could work. That's what I was trying to do.
Just saying that the implementation knows what the base value is.
Yeah.
And will use it. Okay. You're not saying it's implementation specific as to how it makes it up.
No, just it knows what the base is.
Okay, then I agree with you completely.
Okay, so then the only question I have is, do you think it's a good idea to overload the reference URI and make that an option as that a device may choose for producing that offset? So, if it knows something local, and that's maybe where it got its first manifest, for example, then it starts there. And if it can't find what it's looking for there, then it can use the reference URI as a second step.
So that thing would be specified in the manifest. If you can't find it locally, then you can go get it here. I
Yeah.
think that a certain amount of non-determinism, but I think that may be an acceptable amount.
Okay.
What I'm worried about is, oh, and then it went to this ran site that no one really was expecting, and thinking mud files here specifically.
Yeah.
And then it failed because it wasn't allowed to get there because no one knew it was
So-
there.
So interesting point. If your MUD files are somehow associated with your manifests and your network infrastructure knows about this, then you should have a way for your network infrastructure to be aware that there is an update in progress and that these are URIs that might be accessed, and that's legitimate because here's a signed file that says it is.
Yeah, so you're saying that the manifests themselves could drive the network policy without anything else.
Exactly.
That sounds cool.
So just a thought there. Maybe we should think about that some more. So I think we have, like, is there anyone else in the queue?
Yeah, Hank is in the queue.
Yes.
Hi,
Hank?
Brandon. So I think that this is a place where examples are a good middle ground. By not specifying it out, they would provide exactly the non-intuitive guidance that we need. For example, the second example here was mud, but also the if there is no reference URI, it is probably still well known to the context.
Yeah.
So you if it's not there, you assume there will be something there. And then these two examples spelled out in a little, I don't know, user story probably will mitigate the uncertainty here for engineers to implement that.
Yeah, I think the next step is probably to propose some text to the list and see what people think.
Christian?
Just an answer. I'd just like to point out that having two possible base URIs, the one that is found from the context and the explicit one in the document, is not something that's, I think, well supported by RC 3996. So if it's possible, I think it's more straightforward to say that if there is if an explicit base is indicated, then that is the base. And if no explicit one is indicated, then the context may have one failing that relative references just don't work. But
Yeah,
try
understand.
either of them. Fallback sounds a bit sounds like a recipe for boot from drive C, but try drive A first. And if you boot from drive A, yeah, oops.
So I would actually argue for the opposite order. If there is a locally known context, it's probably correct, and the reference URI should be used as the reference of last resort. And that's because we don't know what's happened in the chain of custody on the manifest to get it to where it is. And so that URI might be old or hard to access, or who knows. So my preference would be to start with the thing we do know and then move down to the thing we don't.
I think that can work with the 3996 model. It will just need a bit of careful wording to do that.
Yeah.
Thanks.
Thank you. Shall we move on? Hearing, oh, I have skipped ahead by accident. Where are we? There. Okay. So the next point is that there's been a request for future manifest URIs. And the idea behind this is essentially to advertise in a manifest what the place the update client should look, what the place is that the update client should look for the next manifest. This could be used for update service migration, for example. This is an interesting idea, but my question is, does this belong in the core specification? I think it might not. I think this might be an extension. Should it be component specific? Should it be overridable? And then finally, is it an artifact of secure invocation, secure boot, or is it an artifact of installation? You can make an argument that it should be an artifact of secure boot, especially in the situation where there are severed sections, because that information will be lost. Alternatively, you can make an argument that it should be part of the update section, because that's the application that's going to be doing the work. So I think I probably come on the side of this should be part of secure invocation, but I'd be interested in feedback. And I think the most important feedback on this is, should this be part of the core specification, or should this be moved to an extension?
So seeing no one in queue, I think the fact that there are these questions, that unless somebody comes up with a compelling reason that it needs to be part of the core specification, I think the default answer is put in an extension, because we're trying to get the manifest to be published as soon as possible and move everything else to extensions, right? Move some things out like firmware encryption and so on. And so unless somebody has a compelling reason why it cannot be left to an extension, I think that's the default answer.
Agreed, extension it is. All right, moving on. Integrated payloads. There's a question of whether you should be able to compute a digest directly on an integrated payload. Now, this is a problem because the existing condition for evaluating an image digest only refers to a component ID, which means that you can't refer directly to an integrated payload. My inclination is that this should be referenced by using a new condition. Integers are cheap, and if you've got an integrated payload, then you clearly are not worried about having minimum size of your manifest. So adding a new condition specifically for doing this seems like it's probably the right answer. The one question here that I would have if we were to do it that way is, what should the component ID be if you have an integrated payload? My inclination is to leave it the same as the component ID that the installation ID will be. Installation ID being the place that your integrated payload is copied to, if it is indeed copied somewhere at all. And I think this might be a candidate for an extension. And unless someone has a burning need to have it in the core specification, that is what I would aim for. Okay, no one.
No, just a second. I want to ask a question to your earlier comment. This is just a integer. They're cheap. But that's not true if you stumble across one for the first time and your code's not prepared for it.
True. Yeah.
So that kind of argues for putting, if you think this is an important feature, and that argues for putting it in the base.
I think it's probably an important feature where integrated payloads are used extensively. If they're not being used extensively, then maybe not.
We shouldn't make the decision without answering that question.
Okay. Well, again, I think maybe the step here is to propose some text and take it back to the list, and then we can work out whether this goes in the base spec or not.
Great, thank you.
Okay, next. So there's a question about whether we should use integer references for integrated payloads and indeed integrated dependencies. The issue that I'm dealing with here is that right now we're using integers to reference integrated payloads. Now what this does is it means that the manifest itself has to execute a integer to string conversion, or sorry, a string to integer conversion in order to look up the correct key for its integrated payload, because this is referenced as a fragment-only URI reference. This doesn't seem to me like it's necessarily the right approach. It also actually increases the size more than you would expect. The reason for this is that you can use a shorter string if you are like a shorter URI reference, fragment only reference, if you are using a string one rather than an integer. And that's simply a factor of the size that it takes to represent a number large enough to fit in. So sizes shouldn't be an issue if we were to switch to using strings. The big issue would be having two possible keys in the envelope, either integer or string. That'd be the only real substantial change here. It does have some, one thing that I do think is a big benefit to switching to using a string rather than an integer reference is that we can avoid any possible collisions with future extensions. You can't collide a string with an integer, so that solves that problem pretty solidly. And of course, we remove the string to integer conversion in the manifest processor, which is good too. So if there are no objections to it, I would like to change the integrated payloads and integrated dependencies to be strings that point, or strings that key a byte string.
In chat from Christian, who says +1 on using strings rather than ints. So if I don't hear anything else, then sounds like no objections to your proposal.
Yeah, and it looks like Michael is supportive as well, I think. They do not currently have GitHub issue numbers. I should fix that. All right, next topic then. Oh, right, I went through it without actually looking at the slide that had it. Okay. So one of the interesting options that you would have if you were to follow this proposal is that you could take an optimization option where if you as a distributor wanted to make sure that a device checked for an integrated payload before it went and did a fetch, what you could do is take the URI that you were going to use, or that the device was going to use, and you can see it plainly in the manifest, and put that in the envelope, reference, and put the payload with it, and then your device will go and pull that out of its own manifest because it checks for that string in the manifest before doing a remote fetch. So there's an interesting option that you have there as a distributor to essentially change the fetching policy without changing anything to do with a manifest at all. You simply put the payload in the envelope at the right URI, or with a string key that is a URI, and that's where fetch hits first. So that's an interesting option. I'm not saying that that's something that needs to be mandated, but that's something that maybe we should think about. You know, do you always check there first or not? And again, I think the right answer here is to put some text on the list, given that there's some support for this approach, and go from there. So what this would look like, I put together an example of the encoding sizes, and you can see, as I mentioned before, that the sizing turns out to be pretty similar. The reason 24 is picked there is because the code, the CDDL explicitly states that the integrated payload key must be 24 or larger. So that is the minimum number of bytes that you can use as a URI fragment only reference. All right, and now hopefully I'm on to the next topic. Nope, that's the CDDL for it. Let's keep going. Okay, now we currently have a mandatory to implement digest algorithm. So there's a question of whether we should implement a mandatory to implement signature algorithm. And then the question is, which ones should it be? Based on the concerns about a possible future break in existing public key infrastructure, it seems that making HSS LMS mandatory to implement is probably the thing to do. because that it allows us to be sure that devices can migrate away from compromised signature algorithms if and when a quantum break occurs. But that does put an additional burden on implementers to move to HSS LMS, or at least support HSS LMS right now. And I'm not sure what that would do for this specification.
David Brown and Q, go ahead.
I'd make about this is, I know at least within MCU boot, we generally build a given configuration with only one signature algorithm chosen as supported, and that has to do with binary size and constrained devices. And I'm not sure what the implication would be of a mandatory to implement signature algorithm if many people are going to be building the system with a different signature algorithm and will not want the code spent implementing another one.
Yep, that is exactly the concern. Now, the one comment I will make on that is that the code size for HSS LMS should actually be quite small. The reason for this is because it's based entirely on hashes. And since you've already got a hash algorithm for your other signature algorithm, there's no additional crypto added to get this job done. It's just a question of how much code it takes to implement the processing of that signature.
I know for some of our devices, greater than 0 is too much.
Mm-hmm.
So we have some very constrained devices. So
Go ahead, Michael.
So I take your point that most of the crypto's already there, and there's some other stuff to validate, which is has some code side implications. But I actually think the bigger issue is the trust anchor maintenance on that LMS, HSS LMS, and possibly another one. So if you now have 2 trust anchors to maintain, that's a big deal. And the argument I think becomes, if you're going to have the hash-based signatures at all, unless the signature size impact is, monstrously horrible, then the argument becomes, well, that's the one we're going to maintain anyway.
So the signature size for HSS LMS is about 1280 bytes, unless you use one of the reduced hash size versions. And I guess my question is, should we even do that? And I will defer to the crypto experts on that one.
Well, so it's not megabytes is what I knew that was probably the case, but some people may have been worried about some of the other post-quantum signatures, which were huge. But then, compare that extra K and a half to the size of the firmware that you're going to apply, and maybe that's not so important. And I believe, if I'm not mistaken, that you could then get away with not having any DSA or EDDSA in your boot path, because you'd only have hashes. And
that would give you a code size savings.
There may be a savings in there. If you say that's the one, then you're only going to go with that one, because go ahead.
Yeah, so the interesting thing about that is that it produces a new burden, and that's private key maintenance. In existing signature algorithms, the only thing you have to do to maintain your private key is not expose it. With hash-based signatures, your private key changes over time. Each time you use it, it has to be rewritten. Otherwise, you might sign 2 different things with the same branch on your Merkle tree, or the same leaf on your Merkle tree. And if you do that, then your private key becomes useless. You have effectively exposed it by signing 2 different things. And there's a finite number of signatures as well. So that produces a new and different exciting burden for signers to hold on to. And so I guess what this is about is whether this should be placed in as a algorithm of last resort. You know, when things go wrong, we switch, or whether this should be the standard.
So I just want to repeat what you just said to make sure that I think that I got it and everyone else got it. If I had an asymmetric key, all I need to do is read the private key from my secure storage, use it, and then delete it.
Yep.
Right? Whereas with a hash-based signature, I need to read it, use it, and then update the state on the secure storage that way. And that's
correct.
That's a different ceremony, and it's a ceremony that people will get wrong if they aren't using it every week.
That's right.
So I still see David Brown at the top of the queue. I think, although I think you just didn't remove yourself from the queue when you spoke. So I think Russ is up next. Yeah, thanks, David.
Okay, so I'm the one who's originally advocated for hash-based signatures. And the reasoning is if we don't exactly know when a quantum computer is going to come, but the path for distributing any new crypto is software update. So it'd be really nice if the software update was resistant to that attack.
Yep.
The statefulness that you talked about is definitely true. That's unique to this kind of signature. That is something that you know, the firmware signer will have to be aware of. And I'm aware of at least one HSM implementer who has already taken care of all of that stuff for the signer. The other thing that you should take into account is that validating a HMS LMS signature is much faster than either of the two elliptic curves.
Yeah, you could actually make the argument that the old standby of I'm going to validate this signature and then I'm going to HMAC the digest and then I'm going to switch to using that for every subsequent boot. That goes away. You don't need it anymore.
Exactly. It's that fast. It's and you know, it's a space performance trade-off is the way I see it. Rich, you just jumped out of the queue.
Yeah, and I think I saw a question from David Waltermeyer. I don't know. Do you have audio, David? He had a question in chat.
I don't think so.
See anything, but he said, should we list mandatory to implement in the base spec versus a crypto spec? And should we be concerned about longer term agility? And he said he was going to ask it at the mic. So
No, I thought he said he could not get to the mic.
I agree with Roman. Like baking it in makes sense. The problem with baking in crypto agility on extremely constrained devices is that you may not have any space left for an application once you've got enough agility in there. And that so I mean this is where I take David Brown's point. If this adds any space at all, it might be a hard reject from, you know, and if that's mandatory to implement, then we either fragment the implementation space with non-compliant implementations, or the standard doesn't get picked up. And I don't think either of those is a good answer. So this presents a bit of a problem. I think if we're going to make it mandatory to implement, then we're going to have to provide real measurements of exactly how much code size this costs, and be able to demonstrate that this is a worthwhile venture for that. So I mean, if anyone here is able to produce really reduced size implementations of HSS LMS, that would be really helpful. That would allow us to make that argument. Otherwise, we're going to end up in this point discussing whether it's worthwhile with implementers, and I'm not sure that's where we want to be.
So responding to that, I do think that we should see what the code size for either of these elliptic curves versus HSS LMS is. I would argue that the hash is the same, and so the question is the Merkle tree versus the elliptic curve stuff. And I mean, I have a Python implementation of HSS LMS, and I've open sourced it, so I'm pleased to work with anybody on that. And I will point out that the vast bulk of the code is on the signer side. The validator side is really straightforward and simple.
Yeah, I guess what we just have to answer the question of, is it small enough?
Seems like a really big decision for us. And so I wanted just to repeat what we've been talking about here. I don't think we should make this decision on assumptions, and we should get real numbers and talk through what the trade is, and then be very explicit with, with real kind of data that we're making this trade, because potentially this could lock us in a bad way.
Yeah.
And we should just be very deliberate. Thanks.
Yeah, I agree. And I'd add to that I would also really like to get feedback from potential implementers on exactly whether this would be a stumbling block for them or not. Okay, well, I'll take the argument from that we probably aren't going to have a decision on this today, and that what this is we need further research. So I think that's probably where we have to go from here.
Go ahead, Michael.
So I just want to reiterate that I think that when you said implementers, I think that you were thinking probably of people like MCU Boot. And I know that Russ just mentioned his Python program on that side, but I think there's and he said there's an HSM vendor that had some things. But I think that we're lacking a process, or maybe people call it a ceremony, on the management on the signing side of things, to understand how that is. I think we understand for the asymmetric algorithms, we know how to do that, and we also can build trees of PKI, specifically trees of keys, and it's unclear how we do that from a management point of view at the layer 8 kind of point of view. And I think that's where actually the biggest risk for this comes from, is figuring that out. And so I think we actually need someone to go and do some kind of a trial. I don't know, maybe NIST, something like that.
So
that may.
I guess the other point to make on this is that NIST has only just within the last year actually declared winners for their hash-based signature contest. So these have only just become NIST approved. And that is a risk in and of itself. Not that there's anything wrong with the technology, you understand. I know hash-based signatures are very old. That's not the argument I'm making. What I'm saying instead is that there's a lack of tooling. Not saying anything bad about your Python library, Russ, but
I didn't think you
instead,
were.
what I'm saying is that it's not quite the same as the infrastructure that's available for RSA and ECDSA and EDDSA. So it's a really limited selection of tools available. I would be surprised if you found a lot of HSMs that implemented it. I'm glad to hear there's at least one. That was a surprise, to be honest. So, this is actually the availability of tooling is a real concern. And I wonder if the right answer isn't to make one of the existing asymmetric algorithms the mandatory to implement for now, and then issue a BIS in a while to deprecate it and make make HSS LMS mandatory instead. You know, we can put, you know, a warning right in there that says, look, this is coming as soon as, you know, as soon as the tooling's ready. But I worry that we're limiting the audience if we make hash-based signatures mandatory at this point.
So if we're going to take that approach, I would call it a must and a should.
Yeah.
And that way, we're signaling that this is a thing that we're thinking about going forward. We can even put an extra sentence in there, but the should get someone's attention.
Yeah.
I would be fine with that way forward.
Well, that sounds like a way forward that we can do without having to do extensive research at this point and build a bunch of implementations. So I like that. That moves us forward.
Comment to the chat for Michael. Are you disagreeing with that?
Well, I heard Russ say that it's going to be a must plus a should, a must on hash-based signature and a should on some symmetric algorithm.
The other way around.
Well, okay, so
a
I'm
must
gonna,
on an asymmetric algorithm and a should on the hash-based signature.
So yeah. So, but now you're making people meant two things and higher code size. So that's why I'm arguing that, you know, we're going to wind up with an asymmetric as a should anyway, and we're going to have a may, right? So you have three options there, right? And so you're going to wind up with some kind of anyway. The point is, I don't think we'll ever get to having hash-based signatures as a must if we start off with it as a should. The pushback, I think, will be too big, and it's a voluntary standard, and I just worried that will be exactly the situation Russ worries about.
Yep. Okay, well, I honestly don't know what to do with this one. Well, I think the best thing in the interest of time is to again, this one's got to go back to the list and see if we can get some more input. Maybe we need those numbers for the hash-based signatures before we can move on.
Yeah, I mean, we do need to make a decision at some point, right? And is knowing the numbers going to change I don't think it's going to change the possible answers to pick from, right? I don't know if it's going to change people's opinion on what the viable answer is, though.
Well, chairs, this sounds to me like the perfect time for a poll.
So, Ross, you seem to be the most up to speed on this one. Do you want to figure out how to ask the question? Any suggestions?
So why don't we just ask a poll, do you prefer, and then ask for those three choices. I don't know how to do a three-way poll. It only does yes, no, right? So, but that's the question I really would like to ask. But let's start with, do you prefer hash-based or elliptic curve? And then if elliptic curve wins, we'll ask between those two. How does that work? Okay, so I'll put the question together. Okay, so you're going to click raise hand if you prefer hash-based, and you're going to click do not raise hand if you prefer elliptic curve. Okay, the numbers seem to be stable. Nope, now they're clicking. Okay, so 10 people prefer hash-based, 3 people prefer elliptic curve. So based on the
Alright.
people here, I don't think we need the second poll.
All right, we have guidance from the working group.
Well, I guess the only thing that we should just verify is that those who preferred elliptic curve, is there a strong technical argument that you have that you think would be convincing to anybody else that has not already been discussed? If you have new technical input, please come to the mic. Otherwise, if it is just a preference or for reasons we've already discussed in the meeting, then I think we're done with that one, with that question. Rich Sauls?
Yeah, I don't have strong feelings either way. I'm just slightly concerned about putting too much brand new stuff in a whole brand new thing. That's all. But if the group is fine with it, that's okay. I'm okay being in the rough.
So Rich, I'll just point out that everything in there is more than 20 years old. So there's no submarine patents, if that's what you were thinking.
No, I'm not worried about the submarine patents. And
Okay, no, those are two very different issues, right?
yes,
Okay.
and I know the stuff's gone since Leighton went off to found a company I work for. But yeah, it's all that's okay. I understand. I'm not concerned about the security implications of the technology. I'm just concerned about adding too much burden that becomes a barrier to acceptance.
Yes,
folks.
I totally get that.
Okay, that's it. Thanks.
The argument I would make on this is that one of the ways that we can reduce the burden is that we can actually put in the signature calculations for HSS LMS, not the hashes. The hash algorithms, you have to be supplied separately. But if that becomes part of the suit parsing process, then the argument becomes that the suit parser always has to supply that, and that sort of solves the problem. It's part and parcel. It comes with it. If it's mandatory to implement, you can make an argument for doing that, and that's convenient. So maybe there's an option there. I don't know. This is something that obviously needs some more thinking about, but we have options for making it less of a burden for implementers.
Okay, back to you, Brendan.
All right. Well, let's get this thing moving on. Oh, and I've gotten back to the start again somehow. Sorry about that. Yes, document structure. Okay. So I've had a number of reviews from outside the working group that suggest that the manifest specification is too complex, or even too complex to implement. It's a shame that I updated to version 14, because version 13 was 111 pages long, which I thought would have been ideal for this particular IETF. But that's the only thing it would be ideal for. 111 page, or 113 now, page document is a bit long for what is hopefully a fairly simple concept. So I'm concerned that people are worried that it's complicated, because the actual core of the idea behind it is quite simple. So I've been trying to think about how we could get it down to something that's a little bit more reasonable. One of the ways we could do that is by reducing the core specification to just a small number of use cases. And I have a proposal here for exactly which use cases those would be. So this would mean that exactly what gets covered in a given, or in the core draft, is substantially reduced. There'll be fewer parameters, fewer commands, and fewer examples. And that all sort of makes things a bit easier to explain. So I'm curious whether we have a support for taking this simplification action, and essentially what it would mean is that we would break the current manifest specification out into several documents. So what the core specification would contain is a shorter list of commands and parameters, the ones listed here. And I'm not sure that it makes sense to, walk through that right now, but just it's a reduced set and only the ones that are necessary to get the core use cases to work. And then there would be an extension, a set of extension drafts, 4 of them, I think, which would provide encryption. So that's the one that Hannes is already working on. I think that there probably needs to be a compression and differential update specification, which would again be an extension document. For multiple trust domains, we'd put the commands that have been put together to support TEEP, along with delegation chains and dependencies in there. And I thought multiple trust domains was probably the best way to explain the connection between those things. And then update management as another draft. And that would give you directives like weight and additional conditions like image not match and use before and batteries, battery levels and things like that. So I'm wondering if the working group would support this kind of restructuring. I think it would make the document a lot simpler, and hopefully it would move. It would allow us to move things forward a little bit more quickly. This document has been not quite at working group last call for over a year now, so I'd really like to see what we can do to move it forward, and simplifying it seems like maybe that would be a step in the right direction. So any questions, comments, criticism?
Just a question on the things that are on the slide right now. So encryption is already a separate one. So the other 3, is there anything that you know of that has been open issues raised that would be any other reason to split, or is it just the size that's the deterrent for people to read? Is there anything that you could say that the document could go to last call faster by splitting out those 3? So, for example, early in the session, we had that come up when we said by default the answer is going to be extension because there was those questions we didn't answer, right? Mm-hmm. And so, same thing with encryption, we were split that off so that the rationale at the time was so that the main document could go to working group last call, mm-hmm. right? And take longer. So does that argument apply to any of the 3 bullets there? Because we do have things like TEEP that will depend on the 3rd one there, that one going to working group last call before, because the TEEP protocol depends on it. So yep. In other words, is it going to slow things down or speed things up by splitting it out is my question.
Oh, so speed things up in TEEP is another question. Hopefully not a lot of slowdown in TEEP would be my answer there, because the content of the multiple trust domains document is essentially everything that's already in suit and hasn't had issues raised. The one place where I think there probably are going to be issues raised is actually in compression and differential update. I think that those are not well specified enough that they should really be dealt with at this time. They're things that I wanted to have well defined because I feel they're underserved in the IoT community. But unfortunately, there hasn't been a lot of progress or contribution in that area. So I would be inclined to actually pull those out regardless of what we do with the rest of it.
Thank you, David.
I think you said my name. I guess one question I would have about this, are we putting too much in the base of this proposal? Would we be better off with the core specification being even more simple of just some kind of streamlined load this, something like that, and then those kind of profiles and use cases that we had that you spelled out in the previous slide would be another doc? Just a wondering about that.
The use cases. Here we are.
Or that, yeah.
Maybe. I worry that if we strip it down too much, then it will simply look like this specification doesn't meet my use case. You know, and that'll be the default answer as I look at it, and this doesn't do what I need.
Okay, that makes sense. I mean, it's just a thought.
No, fair enough. I was I'd like to pare it down more as well. But after a certain point, we're going to hit diminishing returns, and that's simply a question of exactly what is the incremental cost in adding one of these use cases. And when we start with the first one there, the incremental cost of adding the additional ones after looks to me to be fairly small. I don't think it's a big incremental cost to add the additional ones.
At least between the first 4 in the section. When you get to 2 images, multiple
no,
images.
that one's actually pretty simple as well. So the reason I say that is because that one is just about the ability to set a component index. That's literally the only thing it adds.
Oh, because you're not talking about dependencies. Okay.
That's right. Dependencies are in a different one. That's it. Yeah.
Hannes?
Yeah, I just wanted to point out that when we started working on the firmware encryption, there was also the impression, at least I had that impression, with that it would be totally straightforward, and we just provided an example in there, not a big deal. And then I stumbled over one issue after the other. My worry is that we may actually see that with other things as well. As an example, the cost with stuff, trying to do an example there, the delegation chains may fall into that bucket as well. So the fact that questions haven't been raised or issues haven't been pointed out is maybe not enough. So that's why I think it's a good idea to separate this out and then have more possibility to work on these more advanced cases, and to get them right, have proper examples in there, not worry about, oh, am I adding another 20 pages or so, just because I cover the ground very clearly. I think the examples really help developers, but of course they add a lot of page count and make everything look super complex. But, hey.
So I think I'm next in queue. So you didn't explain the rationale for what was core and what was the extension. So I'm going to give you a proposed rationale that I think matches your split and have you confirm whether the split is the correct split. Okay. If you think about there are some parts of the suit manifest document right now that are mandatory to implement, and there are some parts that are optional. Okay.
Yep.
And so my hope is that there is nothing that you would split out that is already mandatory to implement, because that would cause breakage or whatever. But you could argue that everything that's optional could be split out, because you're not going to break anything by splitting it out, right? And so hopefully my point is that perhaps the rule of thumb is that anything that is optional goes into a separate spec. Anything that's mandatory goes in the base spec. Okay, it's my question is how close does that match? And so I did a quick check, and so I looked up to say, let's look at, say, dependencies, right? And it talks about in the spec right now, if the interpreter does not support dependencies. So that one is clearly optional. And now if you think about the way people often specify compliance in checkboxes and stuff, they often do it on an RFC number basis, which we all know is bad, but people do it anyway, right? And so at least there's an advantage that says if you split off the optional stuff, then people who follow the bad practice are at least not causing us problems. So
yeah, so that's exactly what's done here. All of the mandatory to implement are in the base spec. A few of the optional to implement are also in the base spec, but only the ones that are necessary to meet a set of reasonably simple use cases. That was the idea behind the split.
Yeah, and for everybody else, Brendan and I and others were talking about in another context related to TEEP and RATs about the need to do like what commands do you support in suit, right? And so as long as all the optional ones are out, it does not change that discussion in any way, right? Because we already have to do stuff to be able to enumerate that, which we're not solving yet, right? And none of it affects that discussion, so.
Yeah, that's right.
Go ahead, Michael.
Thanks. So I guess I'm supportive of this. I think that one of the things I heard from Hannes, and I don't know whether it was a plus or a minus, that as he split off the encryption, he found that the scope of content that he needed to cover was larger. And I think that's because as you split the documents out, you basically wind up painting a crosshair on more of the document to be looked at.
Yep.
So that's a negative from the point of view of getting the thing done. It's a positive from the point of view, we probably actually need to be covering that, and we're missing it when it's in a single document. So I think that's probably good, but it does mean the total number of words and total number of pages that go through is probably going to double.
Yep.
Okay.
So the big thing on the encryption document was actually key distribution. We didn't have any text
right. We missed it,
and
we need to say something about it. Right. So okay. Yep. So we caught that point. It was something we caught early rather than after publication. But so I guess I would say that the key thing in my mind, and I'm going to say that when I've read the suit spec, and I haven't read the current rev, but maybe 6 months ago, was I get to all these commands, and I'm going to admit that in most cases I just hit page down, page down. When I actually write code, I'll come back and figure out what these all mean. But fundamentally, what I'm actually saying is that you lost my attention because I needed the high-level view. And so as long as the core components are within people's attention span who are reading it, then I think it's a good thing, and they have a view. I think that in the introduction and the other things and some of these core use cases, I think we actually need to cover them in the base document that says we support blah, 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 but you need to go see these other documents. However, those need to be informative references so that we're not actually creating a cluster as Michael Jenkins suggested. So we need to say that we also support the blah, 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 but it's through the additional work, which is not a normative reference, so that we can actually get through. But we need to still tell them that it's that their use case is supported. And I think that's where you're going, and so I'm supportive of that.
That's an interesting point. I hadn't considered putting the forward references in.
I've not heard anybody arguing against doing the split. If there's anybody that wants to argue against doing the split, come to the mic. But otherwise, that's what I'm hearing as support for this idea, especially if it means that in the next rev, if it is split, then the base document, we'd like that to go to working group last call as soon as possible. So in other words, if anything that there's an open issue in, if we can somehow make that be optional, and there was the crypto what's MTI discussion, which I don't know what the answer is yet until we get the answer to that one. Right?
Don't think that one's optional.
We don't know the answer for what should go in the base spec. Is that right? Is there anything else that we know of that would be in the base spec that might be an open question right now?
I don't think so. The only element I can think of on that list would be the digest of an integrated payload, and that one is reasonably straightforward, and I don't think there's a lot of corner cases in it. So if that's the case, then maybe the right answer for that one is to just put it in.
Yeah, I mean if you make something that you think is not out of line with what you've heard today, then in my opinion, and it's there, then that would not stop us from beginning working group last call, because the working group last call will solicit the feedback on that to see if we got it right.
Okay, well, I think that's the end of that, or of my slides. So I guess I don't see anyone in the queue, and the chat has gone quiet. So I think I'm done this.
Just don't delete text. Save it somewhere.
Sorry, what's that, Russ? Go ahead.
I said just don't delete text while you're making the smaller document. Save it somewhere.
That's the point of Git.
Okay, so next up is the firmware encryption topic. And who's going to start off that one? Is it Hannes starting that one? Or is it Brendan starting that one?
Yeah, I start and then hand over to Brendan, and maybe you can show the slides so we don't have the same disaster as before.
Sure. Let me share my screen here. So just a minute here while I swap which screen is being presented. Okay, there we go. Hopefully I got it right this time.
That looks good. Perfect.
Okay.
Thanks. Okay. Yep. Next slide.
Just a minute here. I want to get the, okay. All right, there we go.
Okay. So, yeah, we had this virtual intro meeting in May, and subsequently the document became a working group item in July. The 00 submission was basically a copy of the individual draft with some minor editorial issues incorporated, some typos. In the 01, we added an architectural.
Do you want to turn on video while you're presenting?
Oh, sure.
Thanks.
Can you see me? Okay. Yeah, we added the architectural description. I'll have a figure later on. There's examples in there for the AES key wrap, which is, I think, pretty solid. I've started the work on HBKA. Initially, I thought that I could reuse an existing implementation, but then the whole sort of, that was more complicated. I used Stephen Ferrer's implementation, which used OpenSSL, but because I need to obviously have some code to create the examples. But that wasn't straightforward, but I completed that one and need to release the code somewhere as well. So there are still a few missing items there. The examples that are currently in there are focused on the cozy encrypt rather than an entire manifest. I think that's important. There's also currently only a description of the firmware encryption itself rather than the encryption of the manifest, which is also a feature that we wanted to have based on early discussions in the group. Why not substantially different in the sense of like the encryption algorithms don't care what they encrypt, but I think it would still be useful to explain that how this would look like, and that needs to be done. There's also a question mark about whether we should cover or include a discussion about how to maintain the confidentiality of the firmware image once it's on the device itself, because it's a related issue. Once you do the update and then potentially if something fails, you swap it out, for example, to external flash. If done incorrectly, that could easily lead to a compromise and make the whole process of encrypting the firmware image like moot. So that at least from a security consideration section, maybe that's a point or an aspect that we should talk about. This happens. Next slide. One question that came up, and I think Russ, you brought it up, is
right now.
Say again?
We have David Brown in queue. Do you want to take questions now?
Oh, of course. Yeah.
All right, go ahead, David.
Statement about your last point there with the on-device management of encrypted images. We did end up having to deal with a lot of complexity with the interaction of the swap command, where you have an image that is encrypted when in the upgrade slot and is decrypted in the other slot, and then the image that's unencrypted has to be encrypted when placed back in the swap slot. So yeah, there's some complexity, and maybe we should have an offline discussion about the details of that.
Yeah. Yeah, I think there's some operational guidance that one could provide, and some of that operational guidance has been made in the MCU boot project. So I think we should leverage that and make her aware of the potential pitfalls in making that implementation. So there's also some more advanced hardware that actually So normally, and that's what David has just been talking about, is the issue of you need to decrypt the image before you can execute it. But there's also, in the meanwhile, some hardware that literally operates on encrypted image because the decryption is done by the hardware, so you don't need to sort of decrypt and copy around. So that may be also something to describe in the security consideration section, something that hasn't been done yet. Coming back to the document management question and the point that Russ brought up in an offline conversation was for the AES key wrap, we essentially reuse something that is already in the COSI spec. So that was quite convenient, and we profile it for our use case. For the HB key case, the hybrid public key encryption case, that's not the case. So there's the CFRG specification, but of course it's very generic, and it's obviously not sort of written for use with COSI. So the question is, should that functionality be done or moved into a separate document, and only the profile for firmware encryption in this document? The benefit of doing that would be that others could use the HBKE functionality in COSI for their application. It's something I don't quite know, because I don't know what everyone wants to do with COSI, on whether that's actually an issue, but yeah. Brendan?
Just the one thing about that is that there is already something in COSI that's similar to HPKE. The ECDH ephemeral static with AES key wrap gets you most of the way there.
Yeah, that's true. But and that's actually what I implemented initially before I stumbled over HPKE. The problem there is there are a bunch of similar specifications, and they all look like, from a high-level concept, very similar, but they are not the same. So just being halfway there is still not there. So you would, yeah, the HPKE stuff is just incompatible with what's in the COSI spec right now.
Of course, I guess my question is, what would we gain in, like, what's the difference for suit between HPKE and the ECDH ephemeral static?
The benefit and why we picked that one, I think that was one of the discussions we had at the last IETF and also at the virtual intro meeting, was the HPKE variant seems to be the one sort of candidate that at least in the IETF people want to go forward with, because it provides the formal analysis, it provides test vectors, and there's more and more code available, because it seems that the whole hybrid public key encryption has become a popular building block in many of the protocols. So that's why it seems to make sense to focus on that one rather than some other competing solution.
Okay, thanks.
Okay, so yeah, so maybe this is something I should post to the list. It's and figure out what to do about this. Okay, next slide. So a brief recap on what was added to the document, because it will help to understand the discussion that Brendan is going to go into in a second. So what we added there is a sort of a description of the differences between the classical signing case, where the author signs the firmware image, and then of course the device needs to have a trust anchor in there to verify the signature, and that maybe may require some public key infrastructure. Maybe it's in some cases very simple, but when we switch over to encryption of the firmware images, we run into an additional challenge, because the author who produce the software and the library and so on may at the time when it does so not necessarily know what all the devices will be to which this firmware image is going to be sent to, which is typically the role of the distribution system, like an IoT device management solution. And so that list may be more dynamic, and they also may not be burdened with knowing the, for example, in the HPKE case, with the public keys of the individual devices. I think that would be a big ask. And maybe the case that he knows, because the author and the distribution system are in the same sort of company, so to speak. But in a general case, I don't think this can be expected. So in any case, what we concluded on the mailing list is, as a reminder, is that we said that the recipient list must be mutable simply by the, it must be mutable because the author still signs or protects the manifest. And so the distribution system cannot change it anymore. So if because the COSI encrypt structure has to be put into the manifest or the envelope. And so the conclusion was, from the mailing list discussion was, we need to put it into envelope so that someone else, the distribution system, can change it, and the author doesn't need to know what the devices are that this encrypted firmware image will be sent to. But having that said, there are obviously a couple of sort of side effects of that decision, and that's where I hand over to Brendan, which where he discusses the threats and then potential mitigation techniques. Brendan? I think we can also advance to the next slide.
Yeah. So there's two threats that come up here. First is device suppression in distribution. This is different from a conventional DOS because a specific device can be targeted by an attacker that has no access to the network on which that device is. In a conventional DOS attack, the attacker would only be able to suppress all devices or no devices. This allows them to suppress a specific device and prevent it from being updated. So that's a little bit different than a conventional attack, and that's why I think it deserves extra attention here. So what they would need to do in order to get this attack is to simply prune one element from the recipient list. So in order to do that, an attacker would either have to be on path and modify the recipient list in transit. Now, and that is between the author and the distributor. And that's the end node distributor, so the one that distributes directly to devices. Anywhere between that, an attacker that has the ability to modify traffic would be able to do this. Alternatively, if the manifest is hosted on a CDN, any attacker that can compromise the CDN can then prune the recipient list, and they can do it transparently. And it's the transparency here that's really important. Because it's impossible to determine whether the device was deauthorized by the manufacturer or the author. It's impossible to tell the difference between it being deauthorized and it being under attack. And I think that that is a really important distinction because it's a repudiation threat as well as, well, I'm calling it an elevation of privilege because an unauthorized party has the ability to decide whether or not to deny an update to any specific device. The second threat that we have to consider is device energy and flash exhaustion. And the way that this one works is it is a denial of service attack on a specific device. And what an attacker does in this case is they alter the cryptographic material, presumably in the COSI recipients list, but possibly also in the COSI encrypt. And by altering that cryptographic material, they make it so that the device spends the flash cycles and the energy to fetch a payload, decrypt it, and write it to flash before it gets the whole payload and is able to determine that it has a digest mismatch. So by doing this, you burn a whole lot of extra power and a whole lot of extra flash cycles. So we want to avoid both of these. Yeah, yes, I think I've described that all. Yes. So again, the attacker capabilities in this case would be either compromising a CDN or modifying the recipient list in transit. And in the last case, this can be on the same network rather than in a separate network. Next slide, please. So to deal with the device suppression threat, the idea is essentially that the recipient list needs to be signed. Now, each entity that modifies it needs to sign it and discard the old list and the old signature. And that way, each distributor is able to validate the list of recipients on receipt. And because they presumably can validate that signature against a list of known trust anchors or entities that are authorized to make those modifications, then they are able to ensure that only trusted parties or only authorized parties are able to modify the recipient list. Now that signature is really just for distributors. It's not actually needed by the end device. So what I'm suggesting here is that that signature can be discarded prior to delivery to the end device. So what I'm suggesting there is that, assuming that we accept the proposal to use strings as keys for integrated payloads, what we would do here is we would have a map of cozy sign objects, and that would give us the ability to authenticate individual cozy encrypts within the payload, within the envelope. So you have an envelope that contains a cozy encrypt. That cozy encrypt is sitting at a string key reference in the envelope, and then there's a cozy sign, which signs the cozy encrypt object. And as a reminder, the cozy encrypt contains the recipient list. So this allows there to be more than one signature, since there might be more than one cozy encrypt. And because it lives at a separate location in the suit envelope, this allows it to be pruned in its entirety before it's delivered to a recipient. Next slide, please. Okay, right. So here the problem is, this is the other side of it. We want to make sure that the device doesn't have doesn't use a invalid content encryption key. So one option we have is to put the ephemeral public key into the manifest. Now, the issue with that is that that forces the same use of the same ephemeral key for all recipients. And the other option is that we could use channel security between the distribution system and the device. Both of these have their challenges. Next slide, please. Yes. Oh, I think I got myself confused there. I think I was talking about the wrong thing. Never mind. I still think that we have the.
I can talk about the previous slide.
Yeah, if you don't mind.
Really quick, if
Which slide? Be on
one back.
HPK.
Yeah. So just to summarize again, like as we said, we want to put the cozy sign, the cozy encrypt into the envelope. Before that, we had it in the manifest, and so the digital signature covering the manifest also authenticated the cozy encrypt, because HPKey provides also different modes where you can also provide an authentication for sort of the hybrid public key encryption. But in this case, when we move it out and there's no signature covering the envelope itself for the previously explained reasons, and so the issue is it's essentially unauthenticated. So yeah, so as the challenge then is a distribution system or any entity along the path, if you don't use channel security in addition to it, can replace the ephemeral key, and of course can then it can replace the entire cozy encrypt structure all along. So that may be a problem. There's a certain trust required in the communication fabric, if you will, and there are two solutions to that, like as Brenton alluded to, and they both have sort of their advantages and disadvantages, of course. Solution one is sort of literally take this ephemeral public key and place it into the manifest where it would be signed. And the other one is, as mentioned, is to use channel security. And of course, there are maybe other ones like authenticating, for example, digitally signing the use of HBKE with the already provided mechanism. But in any case, regardless of what the solution is, there is a certain overhead that comes along with it, and we should restrict the use a little bit. So we should probably think a little bit about how we do that. And I haven't myself settled on a specific solution myself yet.
Yeah, I've struggled with that a bit, and that's where I came with the suggestion on the previous slide to this one, where we include a cozy sign for each of the cozy encrypts, but we do it separately from the cozy encrypt so that it can be removed for final distribution to the end device. So that, yeah, I think that's option 3. Next slide, please.
Christian was having problems having connectivity with the minutes, and so can we get another backup minute taker to step in for the next part of the discussion? Since Hannes was presenting and Christian was having connectivity troubles, and those are our 2 note takers. So we need somebody else to step up until Christian's connectivity gets back again.
I'll just give it a try and see where we go with the minutes.
All right.
Right. So one of the solutions for dealing with the recipient list manipulation for the end device specifically on the energy and flash exhaustion threat is to put a digest of the content encryption key into the manifest. Now, I think it's important to explain how this is different from AES key wrap. The issue here is that if an attacker were to replace the ephemeral key, then the attacker would be able to replace all of the content encryption keys with ones that they made up, provided that they had access to device public keys. And then AES key wrap would unwrap the content encryption key and it would validate. And then only when it was used to decrypt the firmware would it be clear that it was in fact not a valid content encryption key. So this is protecting against a different sort of layer in that possible attack. And so I think that it has an advantage in that respect. So there are a few advantages for this particular mechanism of securing the content encryption key. It doesn't restrict our use of ephemeral public keys. So we wouldn't have to say there is only one ephemeral public key. We don't need to use AEAD on the content encryption key, which means that we can reduce the size of the per recipient data. The disadvantage is it does increase the manifest size by 1 suit digest, and I think that we probably do need some security analysis on exactly how dangerous it is to include a how dangerous it is to include a digest of a content encryption key on a or in a signed container, since that would possibly allow some kind of correlation attack that I'm not aware of. I think there's possibly some security analysis or cryptographic analysis required there. The other option is to take a page out of the AES key wrap book and include a dummy value that's encrypted by the CEK, which might be smaller than a suit digest, and that might also give us the same validation capability. Next slide, please.
Russ is in the queue.
Before you,
Oh,
yeah,
go ahead, Russ.
I'm not sure I buy your argument.
Okay.
But if this is the case, maybe this is the reason to back up and do the building blocks that Cozy's already giving us, because if we were to do that, we'd be doing a wrap of the CEK and giving us the integrity protection of it right there, which would stop this attack way earlier in the chain.
I'm not convinced. The issue here is that someone who has access to modify the ephemeral public key would be able to modify the content encryption key.
Right,
if they,
but if you were using the the elliptic curve, Diffie-Hellman, AES key wrap method that's already specified in Cozy, the result of the elliptic curve operation gives you an AES key wrap key, which would be then used, and when the CEK did not integrity pass, you'd stop the chain there.
Yeah, so it will integrity pass. That's the problem. So I, as an attacker, what I do,
will.
Just bear with me.
Actually,
What
I
I
think Russ is actually right.
What I would do as an attacker is I would replace both the key wrapped key and the and I would replace the ephemeral public key. Because I replaced the ephemeral public key, I now control the shared secret, and thus I control.
No, not without knowing the private key. You don't.
No, I've produced my own brand new ephemeral public key. I, as the attacker, produce a new ephemeral public key. Okay,
but there's still the static.
And a new ephemeral private key. I use those to create a shared secret with the static public key of the target device. This creates a new shared secret. I use that shared secret to encrypt random data in AES key wrap. I replace the AES key wrapped key with my encrypted random data, and I replace the ephemeral public key with my brand new ephemeral public key. AES key wrap, when you perform the public key operations, will validate. You'll end up with a valid key. According to AES key wrap, it will just be the wrong key.
Right. Okay, so maybe we need to look at using a mechanism that provides a certified static on the other side, which would guarantee that doesn't happen.
That certified static would fix that, but you'd also lose your forward secrecy.
No, because you'd mix it with an ephemeral as well.
Oh, okay. That's a
okay, Hannes, why don't we take
Cozy.
some homework? Why don't we do some homework to see if we can merge that in?
Okay. Yeah, sounds like fun.
But at least we have a path forward.
I guess the question I have for you, Russ, is can you do that one without adding another public key operation on your battery-powered constrained device?
I don't know. I want to look at that.
That was why I came up with the recommendation for putting a digest of the content encryption key in the manifest that doesn't add any new public key operations. I mean, the obvious answer to this is to sign the Cozy encrypt. That's the approach that everyone takes, right? Like, clearly, that's the right answer, except that costs me power, that costs me cycles. So I don't want to do that. And this puts us into this corner case that most of your cryptographers won't look at. And that's where we come up with these strange things like what if I just put a digest of my key in? Then I've got authentication and everything's fine.
Yeah, the problem is, at least in HSMs, you can't digest that key.
I see. Fair enough.
That's what I'm struggling with, because an operation that says, you know, compute a digest over the key register is like,
Okay, fair enough.
do that.
So then the other option that I've suggested down there, which is encrypt a standard dummy value, or indeed even an init vector.
No, that would work.
Yeah, so that's one of the options that we have. You know, you get an init vector and a dummy value, and you encrypt that, and off you go.
Okay, I know we're running out of time, so if we're going to have any time for the charter discussion, we need to.
All right, let's finish these slides off. I don't think there's much.
Yeah, Brandon, this was the last slide, so.
Oh, it was. Oh, perfect.
Yeah, so we can call it now and move on to the charter discussion, since I think we've gotten through all of this one. And I think sounds like between the three of you, you know who's got the act items to do the next steps on this one. So, all right, so I'm going to stop sharing. So now we have the charter text discussion that's in the chair's slides. And I think, Russ, do you want me to share the chair slides again, or do you have it?
Put them up.
Sorry, what was that?
I said I can put them up.
Awesome. All right.
So the only thing that I think we know going into this already is that if we're going to break manifest into a core document and a bunch of extension documents, which we just talked about today, that's not reflected here. Other than that, I don't know of changes, but if we can walk through this, and I don't want to read it to you, but I do want to give you time to read it and raise any concerns that you might have. Please come to the mic line if you have any issues. It's basically a paragraph or two per slide.
Yeah, and I think the one on the slide right now is basically the same as the first paragraph was before.
Okay.
The goal of this is to say by the end of this discussion, we would like to make any updates based on working group discussion and send that to Roman to be approved or whatever for the recharter, which is the process. We want to make sure we take in any working group input now, since this has already been, I think, on the list. So. I think this text is also roughly unchanged.
Yeah, it's very, very similar.
Yep.
As with the first paragraph here, then the new stuff starts. Anyone not ready for the next slide?
Let's go on.
So this is pretty new, and I see a slide. So Brendan?
Sorry. Yeah, if we could back up to the previous slide. Sorry. The security threats are primarily detailed in the information model. Should that be updated?
Okay, we can do that.
Yeah, you're saying that should move from the first bullet into the second bullet. You know, an information model for the suit manifest that includes a description of the security threats.
Security threats, use cases, or user stories, and security requirements.
Mm-hmm.
Okay, that's just truth in advertising. Be glad to.
Yep.
And this paragraph does not mention about how many documents there are. This is only talking about use of formats. So I think this one is still fine.
Yeah, it's when we get to the deliverables.
Yep.
This part about what's out of scope is unchanged.
The bottom paragraph talks about defining protocols, where I think, at least so far, any protocol work has been out of scope for suit, right?
So, right, but that was not added. That was there before.
I'm wondering, in the truth and advertising point, if we want to keep and protocols or
Just
not.
drop
Is
and
my
protocols. Okay,
I
we
see
could
Brennan
drop
and
and
Q.
protocols.
So
Go,
the only
Brandon.
things that I'm aware of that we're looking at the moment are the suit report, which is definitely a format.
Right.
And there's that would be relevant to this. I mean, the other question on this one is whether we would want to include the discovery capability discovery side of the of suit, and whether that's a protocol or just a format. I suspect it's just a format,
Okay.
but that was the only other thing that sort of springs to mind.
I agree that some could classify that as a protocol, and that by itself might be a sufficient reason for leaving the text in as it stands, which, as Russ pointed out, that text was in there before. So, because if you consider capability discovery a protocol, then we don't want anybody to say that that is out of scope. So, because it wasn't before. So, okay. So I amend my suggestion that leaving it unchanged is okay with me.
Do we want to add anything here about discovery?
I guess we could say is also defining formats and capability discovery mechanism that enables. Brendan, what do you think?
Or to enable suit tracker to determine particular manifest and capabilities or something like that.
Yeah, so the to be clear, the capability discovery that I'm talking about is maybe discovery is the wrong word. Maybe capability reporting would be the right way to put it. Essentially, what is needed is that a manifest creator, a manifest author, needs to know exactly what commands and parameters and algorithms are supported by a given device.
Mm-hmm.
And so in order to do that, they need to get a document from that device that gives them a list. I don't know if that's a protocol. I know it's definitely a document. Whether there's a protocol in there as well is, to me, it's an open question.
Gotcha. So as long as, for example, if you're only doing the equivalent of here's how to express the set of what you support in a suit report, right? Whether you put it in the suit report or something else. I'm just saying, for example, if it's in the suit report, then I think it's just a format because you don't have any way to actually query it, right? You're leaving that to some other mechanism, right? So we talked about we had a discussion in a TEEP use case, and any other use case would have its own way of, querying it or whatever. You're saying, here's how to express it in a suit format or some other thing. That I think you're right. It's just a format. It's not a protocol.
Okay.
Okay. And then we could delete and protocols safely.
Mm-hmm.
Now that I understand that. Okay. So Brendan has reconvinced me that and protocols dropping that would be clearer. So.
Okay. Moving on.
All right. So the first paragraph here, we had a discussion in the RATS working group yesterday that I led that was about, the title was TEEP requirements for EAT. And the discussion was about how to dispatch the draft Berkholz suit-rats-claims document, right? The suit-rats.claims document has some claims in it that are system properties that are not really suit specific. And then it has a bunch of claims in that document, which is an individual submission right now, not in any working group. That says, here's a number of claims for EAT that are specific to suit purposes. And the discussion was how to dispatch that document. Where should that document go? Okay. because this text here was written, this first paragraph here was written to say that it would be acceptable if that was presented to suit, then suit would be allowed to accept it. Okay. Now, the result of that discussion in rats is that I don't know if it was consensus has not been confirmed on the list, but I would say the opinions of those in the room was that they might want to do those in the rats working group itself. Okay. Now, the rats working group itself is not required to have every EAT claim be done in the rats working group. Okay, just like the DHC working group doesn't have to have every possible DHCP option in the DHC working group. It just has to be able to review stuff. And so whether you use a decentralized model of development and review by the centralized working group, or whether you do stuff in the core working group, it kind of depends. And so here, if RATS takes it, then there might be no document in the suit working group that we need to do here other than review. And so the word specify here, no, the suit working group will specify, implies that we're going to have a milestone here. Right now, that could go either way. If it gets done in RATS, then then it would be incorrect to say will specify. And so at the end of that, I said this will affect the suit charter discussion. That's just right now, so I'm just bringing that back here. Can we come up with some wording that maybe
how about may
will
specify?
work with the RATS working group to specify?
How about will specify or may specify? Changing will to may, then as that discussion proceeds, we can do it if it lands that way, or they can do it if it lands that way.
Okay, I agree that that is an option. I'm going to argue for the option that I gave, why I like that one slightly better. The option that I gave is we'll work with a RATS working group to specify.
Okay.
And the difference is that one says that it is our charter to make sure it gets specified, as opposed to may means we could choose to do nothing and still be okay. And I think we actually do depend on there being things that get done. And so that's why I would prefer the will work with a RATS working group to specify. And that kind of leaves it ambiguous as to where the document is. And then we would leave that off of the milestones in this particular point of rechartering, because we can always get Roman to approve adding a milestone once it gets worked out to which working group is going to add the milestone.
Okay.
Roman, any comments on that?
Yeah, I mean, I just put it in chat. I mean, since I'm AD of both of them, I'm watching both of it. I'm actually not so concerned because it's clear that the working groups are talking amongst themselves and we can wait. Let's just make sure we have enough ground so we don't have to recharter again if we choose a path,
Exactly.
that's, that's something kind of different than this. Let's just choose something big enough so we don't have to do it again.
Yeah, and my understanding, Roman, is that you don't have to recharter to add a milestone, right? That's just something that you or us can do, right? Okay,
right.
Great.
Yeah, so it's just the key thing is just to get the scope in here.
Yeah. And then here's the deliverables that we have that, Brandon, maybe you could reply to the thread on the mail list and say what extension documents you think we should commit to besides the firmware encryption one, which is here already.
Yeah, so I think really what we need to do is just go through that that separation work for the manifest document. And what I don't want to commit to exactly what that output's going to be, because it might just shift in the next little while, right? So milestones, as you said, we can add them if we need to. So the initial ones that I would suggest are the ones that we had in the previous discussion, right? We have encryption, which I think is already listed here.
Is there, yeah.
Yep. We don't have the multiple trust domains document, so how to handle when you have more than one trust domain for your device. And we don't have an update management document. So that's again, just all those ancillary things you might want to know about if you're managing updates in a slightly more complex way. So I think those are the ones. Now, compression and differential update, I still think that one, I don't think we have enough information on exactly how it needs to work. And I think that's the problem. So do we put it in or not?
Well, so maybe at this level, we just say extension documents, such as firmware and then we can define the milestones as we come up with the ones we actually want to do.
Okay,
What
fair
do people
enough.
think about that?
Seems a bit open-ended, which is the only danger. I don't know. Any advice for us, Roman?
It's a good idea to have some marker in the deliverables or milestones if you added new scope. But if it's a case which I feel like we are right now, we don't exactly know how it's going to pop out. We can cluster markers for future deliverables relative to that scope and work it out. And so when we have a better idea, we can decide to kind of split it and make it a first order milestone as needed.
Well, the other thing is these are extensions to the suit manifest. It's not like, oh, extensions to anything.
Right.
Okay, sometime next week.
Yes,
I'll
my
put
comment is going to be on the wording of the fourth bullet there. We need equivalent wording to say, maybe just add another sentence onto the end of that says, this may be done in the suit or RATS working group or something like that, just because we have a
Right.
deliverable to make sure it gets done, whether we review it or whether we author it as open. So,
Right.
okay. But yes, we are at time, so.
Okay, I'll put forward these ideas into a updated text to discuss on the list. Thank you all.
All right, and thanks again to our note takers, Christian and Hannes.
Guys.
All right, enjoy the rest of your IETF.
Public service announcement for those of you in suit. The TEEP working group, one of the things that's a presentation there is suit examples for TEEP. If you want to see the examples of suit manifests in a TEEP context, come to TEEP working group in about, I don't know, 2 hours, I think.
Thank you, guys.
Thanks, everyone.